Sorry about that, guys. I wasn't aware I was host. Jeff, you're host.
All right, we're back. All right, thank you.
Sorry, boys.
No worries, it happens. I think we've all done that at least once or twice or 5 times.
Cool.
No worries at all.
Yeah, that's perfectly normal.
Yep. All right. Thanks, Sean. All right. So I was just saying basically that, we're going to do a full walkthrough. Please feel free to slow us down, ask as many questions as you'd like. We're here to help you and get you comfortable with OCI and Checkpoint combined.
All right. Thanks, Jeff. Thanks, Sean. So as you mentioned, the intention of this workshop is not to go through a slide, but I'll walk through some basic slides. The intention was just to show like what the outline looks like for this workshop and what we're going to cover and all. So behind the scene, like what we're going to do in this workshop, provide you like a way to provision your resources using Oracle Resource Manager, as well as you can provision resources manually. When I say resources, like subnet, routing, VCM, virtual cloud networks, firewall instance deployment, compute instances, dynamic group policies and all. And we're gonna leverage our OCI marketplace solution. The core concept of OCI marketplace, it allows partners to expose their listings as a click to deploy button. So the idea of like end user or customer, they can go to an OCI console. From there, they can launch those listings pretty easily. Then we're going to focus on how you can configure the Checkpoint CloudGuard in the from command line and utilize the Smart Console and Security Manager to deploy it. Then in the end, we're going to validate the traffic and inspect the traffic as well also. We're going to cover east to west traffic, north to south, and behind the scene, we're going to cover like high availability use case also. So as you already know, this is a Checkpoint OCI workshop. So we're going to use the CloudGuard Security Gateway solution. And we're going to deploy our solution in high availability use case mode. We're going to leverage our OCI to run this workshop. As you already know that OCI allows you to sign up for free tier, but free tier doesn't give you exposure to OCI marketplace listing, which is a prerequisite. So that's why the focus around is you need to have like pay-as-you-go tenancy. Just in case if you don't have that pay-as-you-go tenancy, you can always watch the workshop and it will be recorded also. But if there are any open question or which can be answered from QA panel, and if there are any discussion can be done on the chat channel. So how these listings of CloudGuard expose? So they comes in 2 flavors. One is like bring your own license. Another one is paid listing. Bring your own license is available in US as well as non-US market. Paid listing is currently available in US market for the time being. And they might be available for international market, but currently they are available in US market.
And to be clear, I think what we're trying to say there is that the payment of the paid listings has to be in US dollars. I believe, correct me if I'm wrong, Arun, you could run paid listings in other countries, but in order to use them, you would have to pay in US dollars.
Yeah, but there's some still small caveat, like even the paid listing are not exposed into non-US.
Got it. Okay.
But since Checkpoint CloudGuard is a cool feature, they allow you to use a trial license to run a POC or use case, and which you can always update it and connect with the partners as Jeff and Sean directly, and try to if you want to bring up your own license or purchase a license or ask for a license from partner, you can always do that. But our intention is we're going to use our bring your own license listing, because it gives it is available in all the regions. So it makes it easier for us to go through the workshop.
Right. And by default on the Checkpoint side, it comes with at least a 15-day license, if not a 30-day license by default, without having to contact anybody. So it's nice.
Correct. Yes. So what's this workshop architecture will look like? So as you already know that we are covering the high availability use case. So if you are familiar with the HA cluster, it's a active PSA cluster. One is primary firewall, another in standby firewall. So if you see here, there are two firewall are deployed, and each VCN. So if you are familiar with the OCI terminology or any other cloud, the intention is like you define logical separation of networking. So VCN is one of the object. So we have like hub VCN, then we have spoke VCN, database and web tier. So all these hub VCN and spoke VCN, we are leveraging the DRG, dynamic routing gateway. So DRG is responsible for any on-prem traffic from virtual circuit terminates on DRG, as well as an IPsec traffic from on-prem or any other cloud environment, so which terminates on DRG. And DRG also allows you dynamic routing gateway to communicate between VCNs. So as you see from this topology, we have three separate VCN, hub VCN, web spoke, database. All these three VCN are connected with the DRG. So DRG gives a feature of attachment, which we will cover how you can see those attachments in the routing and all. And then we have deployed two firewall where they are connected, as well as they are using the backend interface to do HA sync, configuration sync and all. And if a primary fails, then standby will take over. And all this routing required object like internet gateway, service gateway. Service gateway is one of the OCI service which allows you to connect to object storage without going over internet. So if your subnet or any spoke VM wants to talk to talk to object storage and doesn't want to go to our internet, they can go to the service gateway. So what we're going to do, we're going to leverage our OCI marketplace to deploy this checkpoint CloudGuard solution, and then we're going to configure them in high availability cluster. Any question before we jump on the workshop part? Hopefully it gives you a good outline what we're going to cover, what is the prerequisite, having a paid account, and what is our workshop architecture looks like.
Yep, and just to be clear, in case it wasn't clear, the DRG is what allows us to do basically zero trust networking or zero trust security between the spokes and the internet, et cetera, and vice versa. So you can imagine a very complex environment being secured just like you would if it was an on-premise environment. The DRG allows us to do that, and it's pretty slick. It's very nice.
Correct. And then in the in between, we're gonna cover I'm gonna show you how the reference architecture looks like. But this is one of the example of high availability reference architecture.
So no questions in the Q&A. So let's go ahead and get started.
Okay, sounds good. So this is the workshop link. If no one has that handy, they can let me share it on channel over here in the chat. So this workshop is around the same use case. If you click on you can try to log in into launch a free trial workshop, but as I mentioned earlier, OCI provides a free trial account, but to run this workshop, you need to have access to OCI marketplace listing, specifically Checkpoint CloudGuard as well as Checkpoint Security Manager. So to do that, you need to convert that account into pay-as-you-go. But the instruction remains same. You can click on run on your tenancy here. This page will take you to the introduction page, which says specifically that you need at least minimum bring your own license listing. This is the same architecture which we opened. Let me open a new tab here. So this is the same architecture of HA cluster, hub VCN, spoke VCN, web tier, and database tier. Same service gateway.
Hey, Arun, can you zoom in?
Mm-hmm.
Thank you.
Okay, so then we have front-end subnet, back-end subnet, DRG, web tier, and database tier, right? So we're going to deploy this into HA cluster. So if you go follow this introduction page, so it says the outline, which we just covered, provisioning or using Terraform part, configuring them, learning how to deploy from marketplace, configuring CloudGuard firewall to support active passive use case, which we're covering, and all. So let me follow the next lab, so which is like getting started page. So I'm not going to cover, but behind the scene is just creating a new OCI account. So if you are not familiar with the OCI, you can sign up a free tier account, and you can follow along to set up your initial account. You will have access to initial $300 as a free tier service. But to run this workshop, you need to convert that account as a pay-as-you-go.
And when he says pay-as-you-go account, he means this an actual paid Oracle account, not a free tier account.
Correct. Actual pay-as-you-go
And
account.
it doesn't require, it doesn't require pay-as-you-go checkpoint licenses, but it does require pay-as-you-go Oracle. So instead of a free Oracle account, you need to actually put in a credit card or some sort of payment to create a full-blown Oracle account.
Yep. So this is the free tier account. So let me jump on the next step, which is that's where the actual workshop work start, because we covered the introduction page and all. So to deploy this lab workshop, there are many two ways which you can deploy. One is using Oracle Resource Manager, or you can follow the manual steps. So I'm gonna cover the using Oracle Resource Manager, and then we're gonna follow along how the manual step looks like. If you're new to an OCI, I will show like how to create VC and subnets and all as an example, and go from there. So there are two ways you can deploy the Oracle Resource Manager. One is like you deploy the resources which are mentioned here, like a couple of CloudGuard, couple of VMs in the web scope and database, routing table, internet gateway, VCN. So that requires a certain number of resources. Another one is like as Jeff already sent an email beforehand, like what are the minimum resources which you can consume. So to support both, we have written a Terraform code to support that. I will show one of them on my running environment and compartment. Then I will share the minimum resources link also. So what you do, you log in, you expand this step task one. So it says that click on this link below. This link will download the checkpoint zip file here locally. This is in a nutshell, it's just a Terraform code. So what you do, like once this Terraform code gets downloaded here, so you go into OCI console. So before I show it to you here, let me share that minimum resources which are required.
And just while he's doing that, I'll clarify, just make sure that's super clear. So by default, the link that we show in the workshop uses some larger size instances. And so that obviously is going to consume or require or cost more from a resource consumption point of view. This new link that he's sharing is a little bit smaller subset of the same workshop, obviously taking up less resources and costing you less on your, if you're doing just a short-term evaluation. So either one will work just fine. We're just giving you a couple of options.
Correct. So let me just double check I'm giving the right information. Yes. Okay. So this is the link which is deploying minimum resources, but I will show both of them how you can use it. So the first step is like, as you notice, I downloaded that stack locally. So go into an OCI console. So if you are new to an OCI console, you just log in using your tenancy and user account. So once you log in, then you can go in the left-hand side. So in behind the scene, what I did like before starting this workshop, I ended up creating some compartments. So compartment, like I'm going to focus on checkpoint minimum resources and checkpoint workshop. So currently those compartments are kind of empty. There are no resources are deployed there. So just for test purpose, let me show it this checkpoint minimum resources. There are no instances here. Same goes for checkpoint workshop. No instances are here. So what you do, like go search for stack here. Stack will take you to the Oracle Resource Manager. Select the workshop which you want to deploy on it, top of it. So click on create stack. click on zip file here, click on browse, and then point it to a downloaded file. So let me hide it here. So we downloaded two files locally. One is for Checkpoint CloudGuard, and this is the new one. New one is just minimum resources. Let me point it to Checkpoint CloudGuard. Okay. So this tells you what is the stack information, like bring your license model, provide the name of your stack, which could be a generic or depending on what you type. Select the compartment where you want to create a stack. Currently, there are a couple of Terraform versions, but 0.14 and 1.0 should both of them should work. So I'm going to choose 1.0 Terraform version by default value. Then you will see there's a compartment also. These compartments are nothing but there are two kind of resources. One is the compute resources, which is like instances and all. Another one is the network resources like subnet, routing, VCNs and all. So in behind the scene, what I'm doing like 2.1, 2.1, 2.2, spoke VM, and select the availability domain, enter your public key here. This is my public key, like SSH public key. If you are new to SSH, you can just create a new public key using SSH key generator from your command line or any Linux utility or any other utility which you are using to generate a SSH key here.
Right, and that's an absolute requirement. If you're more familiar with traditional checkpoint deployments where you can log in with admin, you will not be able to log in with admin when you stand up these instances. You will need a public key in order to log in initially.
Correct. So this is like behind the scene is like this is like which compartment is. Let me point it to workshop is fine. So what's going to do like it's sending what is the compute share for firewall 2.1, manager is like 2.2. Firewall requires at least minimum 2 VNIC, and that's why we are selecting 2.1 for minimum resources. For compute share, we are choosing the E3 flag shape. Same goes for we are putting the public key here. We chose the AD domain. This is the compute default value. Like the current strategy is like creating new VCN and subnet. But you can always modify the Terraform code to exclude, choose the existing VCN and subnet if you choose to. But that will require some changes into this zip file. So currently hub configuration has like hub firewall VCN sideR, and management subnet is the name, but behind the scene is just a front-end subnet. The front-end subnet, the entrance subnet is like backend subnet. Since we are focusing on the minimum resources, you will see like we have changed the names on the generic resources and all. The backend routing table, all those routing table. Same goes for web spoke. What is the web spoke side looks like? Web spoke and subnet looks like. Same goes for database. And as you already know, the checkpoint requires a dynamic group as well as the policy. So dynamic group is like think of this way: how can you connect to the OCI instances and move the floating IP from primary to standby? To support that, you need to create a dynamic group. Those are based on instance principal method. And dynamic group, what we're gonna do, we're gonna attach those instance OSID of checkpoint, these two checkpoint firewall, and those OSID like Oracle Cloud Identifier. So those OSID like are unique to each instance or each resource. So we're going to use those resources value to create the dynamic group and policies. So once you click on it, click on create, and we could have run apply, but I wanted to run the plan first. So in that way, you know what are the resources it's going to deploy and understand different aspect of it.
And also to make sure it's going to work when you do actually run it, right? It'll catch issues, and it'll catch any issues beforehand if you're not familiar with Terraform.
Correct. True. Then let me click on this button again because I thought I might have clicked this one here. Okay. Then I'll go to stack, go to my another compartment, click on create stack here. this is another like where I have like more resources. So since my compartment has a certain limit, so that's why I'm using it. But the recommendation would be to go to the minimum resources. So in that way, you don't consume a lot of resources. Same goes for public key. As you see, like now I'm using 2.4 and 2.4, and there are some, the strategies seem more or less same, but you will see the different name of the front-end subnet, because those are variables which can always modify based on your need. Backend out, table, web spoke, database spoke, but let me modify this dynamic group name, so in that way it doesn't align with the earlier value. Click on next, and in this case I'm going to just click on run apply because I know it will work. Okay, so what's our plan was succeeded for this particular compartment where we're trying to create the minimum resources. Now we can just go and click on apply button. So if you follow the workshop here, so what we just did, we click on the CloudGuard here, went to the stack, clicked on create stack button, updated the variables here, variable name and all based on those value. Click on next, make sure the compartments where we want to deploy, availability domain, SSH public key, click on next. We chose the create new VCN subnet strategy as a default value, because since this is a workshop, we are assuming that everyone is gonna get familiar themselves with how the workshop environment looks like. So click on create. Once we did that, we ran the Terraform plan first time. And now behind the scene, we are running the Terraform apply command. So what we're gonna see once the Terraform apply happens on both compartment, one is the minimum resources, another one is the generic one. We will see these instances, the public IP and private IP, and we're gonna follow the next lab just to walk through like how the environment looks like. But if you are already familiar with the VCN subnets, routing policies and all, you can always skip the lab of lab 1 and lab 2 and directly go from lab 3. But we're gonna cover the lab 1 and lab 2 just to so that way audience understand like what is the lab 1 and lab 2 manual steps looks like.
And just to be clear, what we just did, what Arun just did is we ran two separate instances of the workshop in parallel. So, you know, you weren't required to run both of those. You know, if you were to deploy this in production, you just, you know, you would likely just run one or the other. What he's doing is he ran both at the same time to kind of give to fill up both compartments, right, Arun?
Correct. Yes. Yeah, because I had the resources. I just wanted to show both of the how the minimum resources will look like, and
Right.
as well as how the resources are added here. But you can always modify the Terraform code, because as you know, end user has full control how they want to modify this zip file. If you are not familiar with the Terraform, you can always explore the OCI Terraform provider and update it as needed.
Yep, exactly.
Okay, so our as you see, our apply command successfully got completed. Then what we're gonna do, I'm gonna quickly show you like what is the instances it deployed. Then we're gonna follow along the lab 2 and lab 3 onwards. So 11 and lab 2 onwards. So as you see, we deployed 2 checkpoint CloudGuard. So check CloudGuard 1 and CloudGuard 2, which are using VM standard 2.1 shape, which support like 2 VNIC, which we need for front end and back end. And then we deploy checkpoint security manager is 2.2 because we need 2 OCPU. And then we deploy the database and web spoke VM, only 1 count. And those are like using VM standard E3 flag shape. So which has like 1 CPU count and all. And these like, that's how the minimum resource environment will look like. So if you go into your OCI VCN here, just a quick overview within that workshop compartment. So you will see there are 3 VCNs here which we deployed. If you go into each VCN, then you will see the subnets and all. But I'm not gonna go into details here because we're gonna cover the other workshop compartment where we're gonna focus. But in the nutshell, they both have all the resources. The only difference is the instance shape and size and number of instances in like spoke VCNs. Okay, So this is another one like I should have changed the name of minimum workshop, but I will update the name. So in the nutshell is like apply command got successfully completed. Let me change the name of compartment and that way I don't confuse myself. So, okay. Okay, now let's move to the lab one where I want to show like how the environment will look like. And then we're gonna follow along. So as you see like this manual steps of lab 1 and lab 2, they are focused on like this architecture, like how you can deploy each individual resources and connect them in a way that you can start configuring the firewall and test out your traffic part. So this is the first step of this lab 1 is like task 1, which is like hub VCN. So if you are new to OCI, you can follow along this snapshot. So in this snapshot, as you see, we are going to networking, clicking on the virtual cloud network within our particular region, and then we are entering the VC insider here. So if you go into this our virtual cloud network here, or you can search it on the search bar or burger icon here, then choose your compartment where you want to create your VCN, click on this create VCN, then enter the name here as well as like cider like as a test purpose only which I'm entering, then click on create VCN. You can always create those VCN manually as well as a stack. Stack is nothing but Terraform infrastructure as code like Terraform, and you use them using Oracle Resource Manager or from command line if you choose to. Then this is like a create VCN. So if you see here, in this workshop, our first intent was creating a hub VCN here. This hub VCN name is firewall VCN. So this is the firewall VCN here, which is the particular cider, which is already being created using the Oracle Resource Manager. This is the hub VCN. Then behind the scene, you add two different subnet, front-end subnet, which I will show you, and as well as the backend subnet. And they have their own cider. One is the private, one is public. So this is the front-end subnet. Let me click on no. Okay, so front-end subnet and backend subnet. Front-end is public subnet because I want to connect those checkpoint CloudGuard as well as manager from outside. It's not required, but in my case, I just wanted to connect from internet. So this front-end subnet, backend subnet, their own cider. If you are new to an OCI, you can click on create subnet here, enter the name of the subnet, then choose the compartment, choose the subnet as a regional as well as AD specific. AD specific is not is still supported, obviously. In that way, like for example, you have one AD, like as you already know, OCI has a 3 ADs in general, like for a particular region. If a region is new built, usually you will see one AD. Within that single AD, like the core idea is like it's more of high availability. So in that way, for example, AD1 fails, then AD2 has your resources and application running. If you have single AD, then we have like fault domain concept, like fault domain 1, 2, and 3 within that particular AD. So those are also highly available. So you choose the regional subnet, AD specific subnet, enter your cider here. And just you'll see an error because I'm using the existing cider, which is outside of this VCN range. That's why. Then you choose your routing table. So I'll show how then you choose your subnet access like public and private. Then default value like DNS label, which you want to modify, DHCP option, or any security list. So security lists are tied to, think of this way as Jeff mentioned. So by default, everything is blocked until unless you allow on either security level or network security group level. But since this is a checkpoint firewall use case, our intention is we're gonna allow from our end for this workshop only, but we're gonna control those security lists from checkpoint solution.
Yes,
So you can select
we're allowing the firewall to be a firewall.
Correct. Yes, exactly. Because that should be the intention of the firewall, right?
Yep.
So
exactly.
security list, and then you click on create subnet here. So this is an example of this front-end subnet, back-end subnet, which we were covering. Like you will see 2 subnet here. Then you will see internet gateway. Internet gateway, you can click on internet gateway here, to create a new internet gateway. But since we already have one, you can this internet gateway will allow you to assign a public IP to subnet and go outside, right? But if you are familiar with the like net gateway on OCI, it is more of like if you have private subnet and you want to reach internet, that you can use it also. This is the net gateway here. So behind the scene, if you click on front end subnet, so the use of internet gateway, like you want to assign a route pointing to outside, right? So if you click on front end subnet and you select the security list here, you can update the security list if you choose to. In our case, we are allowing all. So if you click it here, so once it populates, you will see that the ingress and egress rules allow all. Currently, I'm allowing all protocol, but if you want to update them and modify them, you can choose to like enter your CIDR here or particular CIDR, like if you want to do 10.0.0, whichever, and select your service, which one, TCP, UDP, SSH, or any standard protocol, which you can see from the drop down. Then you can add another role if you choose to, multiple role in a single window or one by one if you, however you decide. So behind the scenes,
but like we said, for the purposes of the checkpoint firewall, we're going to want that to be wide open. Otherwise, you're gonna you could see some goofy stuff or not see traffic arrive at the firewall at all that you're expecting to see there.
Exactly. And you can follow the checkpoint official administration guide just to understand, which is covered in the workshop. I will show in the link, but that also tells you what are the required ports and policy which you need to open. Okay, so this route subnet which we were focusing, I was talking about the route table. So if you click on this route table here, if you want to modify the route table, you can modify those values from this drop down here. But the core concept is like, which I want to focus in the route table, you will have the route entries. So route entries are nothing but they are means of path, like how would you want to reach to this particular subnet or CIDR, right? So for example, if my subnet, within the subnet, if you want to reach outside, but I'm saying outside of this CIDR, if you want to reach, go to the internet gateway. So you can modify those route entry from target type, like there are many target type are supported, only like dynamic routing gateway, internet gateway, local pairing gateway, and net gateway, private IP and service gateway. But we are using internet gateway and the DRZ. So DRZ, I will show like how it behaves when the thing happens. So once we cover the workshop, I'll show like when we configure the task for how the DRZ we are using to communicate between VCN and attachments. Okay, so we covered the routing here, so which was like internet gateway we were covering. Then the service gateway is, as I've been mentioned in the beginning, this service gateway is nothing but how if a particular subnet of Spoke VM, they don't want to reach to internet to connect this object storage. As you noticed, like in the beginning, I said HTTPS link. So if you don't want to connect over internet, you can go to the service gateway also. So that's why you need a service gateway to support that effort. So you can click on service gateway here, click on service gateway, enter in the name and the services. For example, if you want to allow only object storage, that's fine. But if you want to allow all the services of Oracle internal network services of Oracle OCI related, then you can go to select that option also. So we had the service gateway here. The ID is more or less same. Then the configure Spoke VCN. So Spoke VCN, as you notice, like core idea more or less same. You click on create VCN to create new VCN. So if you click on web VCN, you will see there is a one subnet here. Within the subnet, we have like one security list, which is allowing all traffic, ingress and egress traffic. As well as in this VCN, we have the one route table. I'll focus on the DRZ in a bit, but what we are trying to say, anything wants to go outside for that particular subnet, use the DRZ to connect outside. So this is the configure web VCN here. Web VCN here, create VCN, and choose your compartment. Once you choose your compartment, then you enter the VCN CIDR name and all, which gets created successfully, which will have the default value security list and all. As I mentioned, you can always update the security list on subnet label once you create a subnet and all those values. But the default value of security list as well the route table, they will remain there until unless you delete that VCN itself also. So you will see there is a application private which we just created from Oracle Resource Manager using the Terraform code. This is application private. Same goes for database VCN. The idea is more or less same. You create a database VCN as a separate entity. Then once you create that, you create a database private subnet within that database VCN. And then you will see the database VCN here also, which you just see there like third VCN, like database VCN, which has a one subnet and the CIDR of this, which we are using 10.0.1.0/24. Then, and the reason I wanted to focus on this dynamic routing gateway. So if you are familiar with the OCI terminology, like earlier you used to use local peering gateway to communicate between VCNs. But now dynamic routing gateway allows you to communicate between VCNs, like close to 300 VCNs. And it's a single entity which supports, and it by itself is a logical entity, which is already highly available within the OCI. So, but the idea of DRG is you can connect all those spoke VCN to a single DRG, as well as the firewall VCN. So the idea of like any traffic coming from web spoke, it goes to the DRG. From there, it goes to the firewall. Firewall inspect the traffic. Based on that, if it wants to go to outside, as well as spoke side, it send it back to the DRG or the subnet via subnet to outside, and then traffic comes back to the spoke VM. So this DRG is like you can search on the burger icon here. You can enter dynamic routing gateway, and within the dynamic routing gateway, once you click on that, you can click on create button here to create a dynamic routing gateway. You can choose tagging resources if you choose to. But we have already created a DRG using that Terraform code. So within the DRG, you will see there are a couple of attachments. So when I say a couple of, like each spoke VCN as well as firewall VCN, they have their own attachment. In a nutshell, like using attachment allows you to make sure that traffic going out or going in follow the same path via DRG. So while that populates, you will see that we just created a DRG here. Click on create dynamic routing gateway, enter your name here, which will populate the remote default value of like a import, route distribution, routing table and all. Within the DRG, you attach a different attachment. So if I go my here, let me just refresh it because populating the value. Okay, so this is like a database VCN, firewall VCN, web VCN. They have their own attachment. But how you can create a new attachment? In my case, since I already have 3 VCN, you might not see database firewall VCN in a drop down. But you can select enter the attachment name here. So firewall VCN 1 or 2, and then you choose the attachment value, right? Let me just select from here. So if we click on one of the VCN, it should take you to this. I just wanted to confirm if they're in the same compartment. Yeah. Okay. So this is like a workshop one, which is like firewall VCN attachment. Click on the firewall VCN here, and creating those new value, it will populate to what is the like if you want to attach a routing table, like DRG route table, what will be the DRG default value. So we had created 2 route table. So once we follow the traffic path, I'll show you like how the path follows. But since we are following the workshop outline, the first one like creating DRG, creating different attachment for firewall VCN, web spoke VCN attachment. We are choosing the default value in the beginning. For web VCN also choosing a default value for database and web. Then we are creating dedicated routing table, like 2 firewall. So what you do, like go to the DRG route table here, click on click DRG route table. So then enter your CIDR which you want to use. Then you say what is your how you can reach to this CIDR, right? So you choose the firewall VCN attachment here, or if you have like any remote peering connection, you can choose that. But in our workshop we focus on the VCN attachment part. and you can add multiple routing rule here. So as you see, we created 2 firewall route table using that the Oracle Resource Manager stack. But what we did, like we pointed all the default route table going to the firewall VCN attachment. So the intention is any spoke traffic coming from a spoke traffic, they will see this DRG using the DRG attachment. They will come to the DRG, and from DRG attachment they will see 2 firewall route table, because 2 firewall route table, it will take to this VCN attachment, and this VCN attachment has its own route table pointing to this VCN ingress, which is, let me just show it quickly here. This is the route table. So traffic comes from spoke VCN, it sees the 2 firewall route table to their attachment. They will see, okay, I need to go to the firewall VCN attachment. Click on it here. Then you will see there is a route table called VCN ingress route table. So if you click on this VCN ingress route table, it takes you to this firewall VCN itself, like which is hub VCN. Then you will see an entry for pointing to the private IP. So this is 2.131. So 2.131 should be the one of the primary firewall of Checkpoint CloudGuard. For the whole intention of this workshop is to sending the traffic from spoke VCN as well as from outside, pointing to the firewall, primary firewall. So this is like a traffic comes from spoke DRG, it goes to one of the firewall. So if we click on this VCN, which we just clicking here, let me open this new tab. This should take me to the primary firewall instance. Click on attach link here. Okay, as you see, it took me the CloudGuard primary instance. So primary instance has like 2 interfaces here, which we're gonna cover in the next lab. But the idea was, once I wanted to show like how the traffic will come to the firewall from the spoke side via the DRG attachment. So we started 2 firewall route table, and how would the return traffic from the DRG of firewall VCN go back to the spoke VM? So to support that, we have, let me go back to this dynamic routing gateway. So think of this, okay, this takes some time to populate because it sees all those attachments and routing tables and all. Okay, so traffic comes from firewall VCN. So it's gonna see this from firewall route table. This from firewall route table, we are dynamically importing the route from the each spoke VM using the import route distribution functionality of DRG, right? So if we click on the transit spoke route import route distribution, you will see 2 entries here. Those 2 entries are dynamically learning about the web spoke sider as well as database VCN sider. So that's how the return traffic from spoke from firewall VCN will know how to reach to the database VM spoke sider as well as web spoke sider. So that's why we are creating this from firewall route table, and then we are attaching the from firewall route table to the firewall VCN. And how you can attach those route table, that's pretty straightforward. Like you click on the database, for example, database VCN, you click on edit, click on advanced option here, then you choose the route table which you want to assign. And then since our firewall VCN has its own VCN ingress route table, so in that way we had to assign this VCN ingress route table here. So click on VCN route table and choose the value from here. So this VCN ingress route table is responsible to send the traffic, any incoming traffic to the DRG, to the primary firewall of Checkpoint CloudGuard solution. Okay, so we see an example of how to attach different route table for each VCN attachment. You will see it from here. So that's the only thing which we are covering. We saw an example of transit spoke, how you can dynamically import the routes from the web spoke and database spoke sider, and then how you can attach those import route distribution to the firewall VCN attachment or the route table. So one thing which I wanted to show it here, those import route distribution are coming here. So you click on create import route distribution. From there you can add multiple statement here. So you can choose the attachment here, then choose the VCN attachment, and then you choose which VCN attachment you want to point it to. Okay, so those route table on each VCN. Okay, so that's the one which I was focusing. Once you create those DRG, you have to modify VCN level routing, right? So let's take a step back and follow from the spoke VCN. So I will pick one example of web and database because the core concept will remain same. Click on the route table of web VCN subnet. Go to the route table. Then if we are doing this, you will see this DRG, because once you click on this add routing gateway, if you select the dynamic routing gateway, dynamically it will know which there is a firewall DRG is attached to this VCN. So because we had an attachment, that's why it knows about that. Then you say which CIDR you want to send it to the DRG. In my case, I'm allowing all, but in production environment, you send only the traffic which you want to send it to the firewall. But there's an important concept here. Like for example, if you want to inspect the whole VCN CIDR of spoke VM, then you need to ensure that you assign the whole subnet CIDR to this subnet. So if you see from here, I have used /25. But if I have like another CIDR, like let me create one. Test subnet. I'm going to choose the default value, private subnet. I think it's by default all. So if you have a VM sitting in this subnet CIDR, it's trying to talk to this subnet CIDR VM, they won't go through the firewall, because how the subnet routing works with VCN, like if you want to inspect via firewall, that's the whole intention of us deploying firewall as a separate VCN. So this will act as a transit VCN. So in that way, any spoke VCN go to this transit VCN to inspect and route or control how do you like IDS, IPS, threat inspection and all, everything what you want to do via the firewall capability. But if you have like a couple of subnet within this VCN, they won't know about, because traffic won't even go to the DRG. Traffic will within the VCN, they know how to reach each other via the VCN routing itself. So that's why it's recommended to make sure that you assign, you have your own dedicated spoke VCN and assign the whole subnet CIDR to this your subnet. So in that way, you can inspect the whole subnet. And that's why I didn't create this subnet beforehand, because I wanted to show like this subnet, if a VM is sitting in this subnet and trying to talk to this subnet, they won't be inspected by a firewall. Okay, so this configure route table are nothing which we focus on dynamic routing gateway, on the web VCN, updating the route table entry, then choosing the CIDR, which is like 00 in our case, you can define your own route entry, then updating this is an example of a routing entry. Then this is a route table of database VCN, same way for which we did for web spoke VCN, database VCN core concept is more or less same. Then the security list, as we focus in the beginning, you can create a new security list here. You can add the ingress route table as well as egress route table entry from GUI. Everything is supported from API and Terraform point of view also, but this is just a GUI. You choose your compartment, enter your CIDR here, choose the IP protocol for ingress, and similarly, you can add another ingress rule if you choose to. Same way, you can do the egress rule also. But unless you don't allow it, traffic will be always stopped. That's by default is blocked. So we did like, this is an example of internet gateway, which we already covered in firewall VCN. Like you have internet gateway, and that internet gateway has a route on the default dynamic routing gateway. No, sorry, default route table. So we had the VCN ingress also, which we covered on the firewall VCN. So this is like firewall VCN has a couple of routing table. You can create a new routing table by clicking on this button here and add a route table entry here by choosing how do you want to send the traffic, whether a DRG, internet gateway, private IP, or net gateway, or LPG or service gateway, depending on your use case. But in our case, like we had to have two subnet, like one is a backend route table, default route table is for front end, and VCN ingress is responsible for incoming route to the firewall. And software gateway is responsible for any traffic destined to return traffic from the software, service gateway pointing to the firewall, back to the firewall. So this is like just a quick overview, like what is the route table, how you can add them, service gateway routing table and all, and security list, which we already covered. So we already show like how you can attach the VCN route table on the DRZ side. Okay. Now a quick summary, like how you can launch the instance. So it's pretty simple. Like go to compute service, search for instances here, click on create instance, enter the name of the instance, and you choose your AD specific. If you have single AD, you can always choose like in the networking section also. Like you can choose different fault domain and all. Choose your Oracle Linux platform images from here and update the compatible shapes. So we are focusing on Spoke instance at the moment. So you choose your AMD Intel shape and all, and you choose what is the required CPU values and all, and then memory as well as any different shape which you can choose.
Yeah, and Checkpoint does support both the Intel and the AMD shapes.
Yes, true. So as you will see in the next slide, Checkpoint supports both of them. Then you click on networking here and choose where you want to deploy it. Like you choose your VCN here. In our case, like since we are focusing on Spoke VM, you choose your Spoke VM Cider VCN Spoke VM. As you can see, test subnet is also populated here. Choose your application private value. If you want to assign a public IP, then you need to have a private subnet. Sorry, public subnet. Then you can click on advanced option here just to see what's the value looks like, any private or IP which you want to assign dynamically. And if you are familiar with an OCI supports para-virtualize, like as well, like which is standard networking, and hardware assistant networking like SRIOV. So depending on the firewall vendor, so it supports both of them. Then you assign a public key. So public key was nothing, pretty simple. Like you can download this public key, private key locally, or you can upload your own public key using browse option, or you can go into like directly upload the public key if you choose to. And you can add another. So in a nutshell, is nothing but it collects those public key and push them into authorized keys of your instance. Then you just click on create a stack, or as well as create it locally as an instance. So in this workshop, these like last two tasks, they focus on launching those instances on web app 1, web app 2, like two different AD or fault domain, and that's similar to compute instances in database or Spoke VM. Any question?
Doesn't look like it. It's probably as good a time as any to take a quick break. So why don't we take a, unless you is that okay with you, Arun? Take a quick
Yep.
take a quick break. All right, let's take a quick. Let's do a 9-minute break. So we'll start at 15 after the hour. So whatever time zone you are in, we will start up at 15 after 1-5.
Okay, sounds good.
All right, thanks, Arun. And
Thanks,
if you have
sir.
any questions, feel free to put them in the Q&A or the chat. Q&A is a little bit easier to track for us, but feel free to ask any questions you might have. Or if we went over something a little too fast for you, we're happy to go back and review it. Thank you, everyone.
Thank you.
Or if you have any other questions, just curiosity or whatnot. All right, Arun, shall we continue?
Yes. All right.
Alrighty.
Thanks, everyone. All right, Jeff. So I'll continue from here. So as you notice, like until the last comment, we were covering like a different task of this particular lab 1. So the intention was just show like what are the different networking resources, how you can create instances, all those based on this topology which are required. Now the next lab we're gonna focus on like how you can launch instances from like specifically those CloudGuard instances from OCI Marketplace. So if you click on this next button, in the beginning, as I mentioned, like there's an official deployment guide as well available on each section. So if you go into, for example, deployment CloudGuard Lab 2, so click on Lab 2, click on here, it will take you to the official checkpoint deployment guide on OCI also, which you can also follow along. But this workshop should give you in detail like instructions step by step if you choose to. Okay. So now this lab 2 environment, the focus is like how you can deploy a checkpoint CloudGuard solution and what are the initial supported configuration on not the configuration on the checkpoint itself, but more of around like HA cluster, like assigning floating IP, creating dynamic group policies and all, and any routing table which are required needs to be updated. So first one, okay. So if you know the checkpoint CloudGuard, you should manage the checkpoint CloudGuard using the security manager, which is a pretty industry and production standard approach. So the idea is like both of those checkpoint CloudGuard security management, as well as checkpoint CloudGuard as a next generation firewall, which is available as a bring your own license model on OCI Marketplace. So they are available in all those regions like which I talk about. So if you click on go to an OCI console here, search for all application here, which will point you to the marketplace. So you can search for marketplace itself also as a keyword. So it will take you to this marketplace instance. So from there, you should be able to search for checkpoint here. So you will see there is a checkpoint security management, bring your own license model, as well as this is the one which we are focused on, checkpoint next generation CloudGuard with threat prevention and all. So if you click on here, it will take you to the click to deploy button. So the intention is checkpoint partner, our partner, like what they do, like they expose this, they bake these images pre-built, and then they expose those images via marketplace listing. So a customer of Checkpoint and OCI, they can go to an OCI console and they can directly go from marketplace and consume their listing directly. So they don't have to like go to the pain of procuring the custom image and all, and they can follow the certain version also. Like if they're looking for a particular version, they can see what are the supported version on OCI. So it makes life easier for customer as well as partner too, once it gets exposed on marketplace listing. So you choose your compartment, choose your version here, choose your compartment, and you need to subscribe to that particular image. Behind the scenes subscription is nothing but it's just accepting the terms and conditions like any industry standard partner or any solution which you deploy. So you can review them, and if you choose to, then you select those check mark here, and it will tell you like bring your own license. That means you need to procure a license or have your own license handy to support that your use case. But Checkpoint also allows you like free trial, like 30-day license, which gives you like some standard traffic validation and part and all, which you can use it.
Yep, and then those instances can be converted to production instances without redeploying. So we can easily add production licenses to those evals, and you're good to go.
Yep, that's true. So if you click on bring on license here, click on launch instance here. So this launch instance will take you to the compute instance page. So as Jeff was mentioning in the beginning, like what are the compatible shape of a particular listing, you can select on this change shape here. Then it will tell you what is the VM standard E3 flex is supported. You'll see a yellow mark. That means it's not there at the moment. So you select the Intel shape here. So it will tell you what are the VM standard 2.2 or 2.4 and all. As I focus in the beginning, like VM standard 2.1 gives you certain OCPO and certain bandwidth as well as certain GB memory but our focus was like we need at least minimum 2 VNIC. So that's why the minimum which you can go is 2.1, because we need 2 VNIC for front end and back end interface.
Yeah, and from what I'm aware of, that's actually unique in our, versus our competitors, that we can go as small as a 1 OCPU shape, or a 2 VNIC minimum,
Correct.
which allows you to save a lot of money potentially on your deployments.
Correct. Yeah, that's true. And you can select those shape, and as you already know, Checkpoint is supported those certain compatible shape, which can fall into your use case, and see how would you like to utilize that. So once you select that particular image version, so it will take you to this this image, and instruction of that image will populate here. You will choose the same concept, like you choose your VCN here, firewall VCN. You choose the front-end subnet where you want to deploy, assign a public IP here, and you have to make sure that you have the public IP pool, and then you upload your key, and your if you want to upload your particular key, you can choose it. In my case, I'm just using public key, which is already being provided using the Oracle Resource Manager. Then if you want to modify the boot side, you can choose it if you choose to. And this is also like a cloud init configuration, so it's like bootstrapping. I know Jeff can comment more on that, but the intention is cloud init support you to do initial bootstrap configuration of your instance.
Yeah, at the moment, we do not support cloud init with the Oracle images, but that is something on the short-term roadmap.
Okay, but you do support running a shell script where you can pass the SIG key in and all, right?
Exactly. Yeah, we do provide some built-in functions into the image build out that allows us to automate portions of that, like the public key and the first time, the SIG key, etc. So
this is one of the example of automation which is Checkpoint and OCI has written. So the idea, when we are focusing on cloud init part, let me click on one of the repository here. These are nothing but Terraform code as well as XM shell script and all, which are exposed to end user. They can go there and deploy it. So if you click on one of the compute TF Terraform resource, resources are nothing but object which you want to deploy on OCI. So in this case, which is HAVM. So if you see it here in the metadata, we are passing this user data. So this user data is the cloud init script which we were talking about, SIG keys and what is the template name and version, allow, upload, and download. So this is the script is written here locally, and behind the scene this shell script has some pre-populated value as well as some variable which it takes it from your Terraform code. And you can use this shell script to do the initial configuration of SIG keys and all. Okay, so what we want in this workshop, the first one is Checkpoint security management, and the idea is remain more or less same. You search for security manager, you choose what is your shape, what is your network, subnet, add your SSH key, choose your version. Our workshop is focused on R81 version, and then you deploy it from here. You can also select those images directly from here, not from Return Marketplace. Let me go to instance here. But it gets easier if you go through Marketplace via console. But if you want to launch it from Create Instance here, you can select your images and choose the partner image. But you may have to search, go to that particular listing name and all, and find it out from here. So you'll see this one, not this is CloudGuard. This one, security management. This is the management platform, and this is the bring your own license firewall which we want to use. Okay, so the next one is what we want to focus. This is the CloudGuard management which we just deployed. You will see this cloud init which we talk about. This is an init script which you can pass as a security SIG keys and all, anything like that. Same goes for CloudGuard 1 and CloudGuard 2, which were deployed. In the first, which I want to focus here, once you create an instance for the first time, you can have only one VNIC interface. So that's why the recommendation would be like you use some kind of an automation which you can dynamically assign the instances pretty quickly, or you assign an instance afterwards, and then your firewall understand, okay, there's a new VNIC is attached, and you will understand, firewall will recognize the MAC address of the VNIC and all. So what you can do, like you can go to your instance here. Let's go to one of the instance, CloudGuard 1, which is your primary firewall. So once the instance comes up the first time, you will see only front-end interface. The reason you are seeing that second interface, because we are using Oracle Resource Manager to deploy the Terraform. Using the Terraform, we are provisioning another VNIC during the instance launch. Like as soon as the instance starts running, we are creating a new VNIC over here. But from GUI, you can click on create VNIC here, enter your VNIC name, like test example, test here, choose your VCN, which you want to point it to VCN, select your network type. VLAN is like another feature, layer 2 VLAN, but our supported use case is the subnet at the moment. So in this workshop, so select your subnet from drop down if you want to. Skip is to support a firewall use case is like make sure that you want to route the traffic to your firewall. So that's why you need to make sure that you disable the source and destination check on that particular, because firewall is going to do the inspection part here. So assign a private IP as an optional value, or if you want to put the host name, if you choose to, you can do that. So once you do that, then it will attach another VNIC here, and that VNIC will be recognized by checkpoint. So correct me if I'm wrong, Jeff. Does checkpoint and recognize those VNIC dynamically, right?
Correct. It does.
Okay, yeah. So that's another beauty of checkpoint. Like you can attach those VNIC, and it will recognize what are those VNICs MAC addresses now. If you want to verify, you can verify from checkpoint console or the CLI. Okay, so what we saw, like we created 2 checkpoint CloudGuard instances. Yeah, I talk about like checkpoint creating a relational interface on how you can do that. Then same goes for another like checkpoint CloudGuard 1 and CloudGuard 2. Okay, so this is one of the tasks which focus on creating a floating IP. So if you are familiar with the checkpoint HA cluster, so the intention of it is like you assign a floating IP here on the primary firewall. That floating IP is available on both the subnet as a separate value, front end as well as back end. And this floating IP is responsible for traffic, as well as like when the firewall fails over, this IP moves from one firewall to another firewall. And to move those IP, we had to create those dynamic group and policy, because it uses the OCI API to find out what is the IP address of this particular instance and VNIC, as well as this particular VNIC, and move those IP dynamically from primary firewall to standby firewall. And to support that, Checkpoint has written some custom plugin, which is already part of their marketplace listing. And so that way, customer doesn't have to do anything separate. It's just that they have to create a dynamic group and policy and add those instances also here. So we'll focus on that particular lab.
Yep, and we'll see that in the lab. Basically, we need access to the API so we can move those addresses on your behalf of the virtual IP.
Correct.
The other thing to point out is that the cluster Excel code that we use on our traditional on-prem devices is the exact same code we use here. The only thing different is how we move the virtual IP.
Correct. Yeah, the only difference is like just a plugin talks to the OCI API, but the core idea will remain same. So this is the floating IP. So how you can assign the floating IP? So let me go to primary firewall, go to a particular VNIC here. And since we already assigned the floating IP using the Terraform, but if you are doing manually, you can click on this assign secondary private IP address here. Enter those private IP as an optional. Otherwise, it will, based on the DHCP, it will pick the IP for you. And select the reserved public IP. So this public IP is responsible from north to south as well as outbound internet traffic. If your use case requires internet connectivity, you can select the existing IP from drop down, or you can create a new public IP here and within your particular compartment. So in my case,
and just real quick, you can add additional floating IPs. You're not restricted to just the one. So if you have other resources that you want to statically NAT or to hide NAT behind unique IPs, you can do that. You can attach additional floating IPs, not just the one.
Oh yeah, that's a good call. Yeah, you're not restricted to use only which I mentioned on this, like 2 of them. But if you want to, you can assign more IPs. But that will require consumption on your end, as well as make sure you have the net policy and routing assigned to your firewall.
Correct.
Okay, so this IP is like same go front end, requires like one floating IP as well as public IP in our case, so which we need, as well as if you go into backend interface, which will require one private IP because backend is more of a private subnet, which is responsible for east to west traffic and traffic from north to south, like outbound, it goes to the backend to the front end interface. So you will see one of the floating IP. So let me just show quickly, like on another CloudGuard instance too, you won't see those IP there because the intention is once the HA failover, you will see those IP moved over from CloudGuard 1 to CloudGuard 2. So if we click on one of the interface here, as well as backend, there is no additional IP here at the moment because our intention is we're going to show the high availability failover. So the IP for which is on the 2.131, they should move to this backend interface once the failover happens. And to support that, as you noted, like the next task of this workshop is like you assign those public IP, private IP, then you configure the dynamic group and policies. So if you search the dynamic group here, so it will take with the dynamic group. Dynamic groups are defined on the root compartment level. Just in case if you don't have access to the dynamic group, make sure you have or like any tenancy admin can create the dynamic group for you. So this dynamic group you will see here, this dynamic group has a certain instance OSID. These instance OSID are nothing but the checkpoint CloudGuard instances which we just created. So we click on this particular instance here. Go to CloudGuard 1. So let me pick an example of ILQ. So if you go into dynamic group here, so this is the ILQ. So one of the OSID of the dynamic CloudGuard. So what you do, like you edit or you can click on this one also, or you can click on the rule builder. From there you can add another line, something like shows instance OSID. And our use case, like we want to focus on instance OSID, you enter those values here. So these dynamic group, once you define them, it needs to be called by certain policy. So as you already know, the OCI, everything is based on the policy, all the resources and all. So you need to make sure that you point this dynamic group in a certain policy within that particular compartment where you want to utilize this dynamic group. So if we click on policies here, go to final resources compartment where we are focused on. So click on here, you will see this allow dynamic group, this dynamic group name to manage all resources. All resources is not required. Like in your case, you can send a virtual networking resources and compute one. But since it's a test environment, I went ahead with the all resources. But still, it's still restricted because I have assigned only certain dynamic group. I want to open it for all the instances and compartment. So only those 2 instances will have access to certain resources and all. So this is the dynamic group here, adding the instance OSID here. How you can find the instance OSID, which I showed you. And if we go into particular instance, then you will see the instance OSID value here. You can just copy it from the copy OSID here, or you can go into particular instance and copy this command here. From there you can copy the instance OSID. So we created a dynamic group, added the rule builder of the policies. So once the policy is assigned, okay. The last step of this lab 2 environment focus on like how you can see those different instances running. So just to verify that you have all those CloudGuard as well as manager as the web and database firewall, sorry, SPOke PM. So we have like 2 CloudGuard running, 2 database PM, 2 web VM, and 1 security manager. Any question before we go into the next step? So let's these are just routing table which we already covered. So one which I want to focus on VC and ingress, because that's important here. So if it go into this VCN here, or the firewall VCN, we have the VCN ingress route table. As you might have noticed, this VCN ingress route table is responsible to send the traffic to the backend. So this is the backend VNIC, secondary floating IP, which is responsible for traffic coming from spoke, go to the DRZ, and comes to this firewall for inspection. So like this is the backend backend interface floating IP. That's what we are in this. We are updating the route table, making sure all those route are pointed here also. And we have also added route table like for backend. So if you go into firewall VCN and this backend subnet of firewall, not the front end, backend subnet, click on the backend route table. So you will see like the return traffic to the spoke VC insider. They are going to the DRZ, and traffic towards the object storage, they are going to the service gateway. So this firewall DRZ, as we showed, we will also see it again, so how the traffic works for the validation part. But the DRZ is responsible for VCN traffic in, back and forth from firewall VCN as well as from spoke VCNs. That's like in a nutshell what we are trying to do it here. Software gateway, we already covered the service gateway part, and this is the last one, like which tells you what, make sure that you have the correct routing table assigned to that particular name based on if you're following this workshop guideline, and you will see those just to verify how you can update those values, which I showed in the beginning. Like you can always update the route table based on what you want to point it to. Okay. Now the fun part starts, like how you can configure the Checkpoint CloudGuard instance as well as management platform, and how you can connect to them. So just a small caveat, like as you already know, the Checkpoint allows you to manage the configuration from Checkpoint Security Management. But to connect to the Checkpoint Security Management platform, you need to have Smart Console also. So you will see in the task for like how you can connect that. But I just wanted to pinpoint before that Smart Console runs on Windows VM. So any Windows VM or any, which could be an OCI or your local machine, as long as it has the Smart Console software installed, which has a connectivity to management IP of Checkpoint management platform, you should be able to manage your firewall.
Yep.
Okay.
Right.
So this is, as you already know, every lab has its own prerequisite. So just I forgot to mention in the beginning, but as we already talked about, you need to have paid account. So what we're going to focus on, initial configuration of management first, then we will move towards the primary and secondary firewall. And I don't have a Smart Console installed, locally installed, but what I'm going to do, I'm going to create an OCI instance of Windows VM. So let's move on directly to the management platform first. Click on instances here. Okay, the reason I didn't pass my public private key, because in my SSH terminal it already knows about my private key. So that's why. But if you want to point it to your private key, you can always do that by using -i flag, right? So okay, so that what we're gonna do, we're gonna set up the admin password first, which allows us to log in from GUI. So we can enter those password value which I mentioned on the lab. But it's recommended to use your own unique password, not this workshop password. This is for this test purpose only. Okay. So once we do that, we should be able to go to the GUI and connect over HTTPS. And the unique password, which is just enter. And so it's going to follow some certain initial configuration outline, which we're going to follow. It's already mentioned in the workshop, but I will show like how the what is the required initial configuration will look like. You will see this wizard here. Click on next button. So it just tells you that this is Oracle OCI platform. Click on next. Continue with the R81 release, which we are using. Keep those values as a default because those are coming dynamically from the management interface. So nothing, no changes there. Enter the name of the host name. So we're going to do checkpoint manager. Update the DNS record if you choose to, pointing to any external or OCI DNS or your own DNS server. I'm going to keep it default for the time being. Update the NTP server based on your own value. I'm going to choose the Pacific time. Click on next. Then it's going to tell you it's going to support it to run and or like a security. It can be used as a security gateway as well as management platform. But in the next button, I'll show like we're going to use only for management platform because this particular instance is dedicated for management configuration and the instance.
Yeah,
So
this
we're gonna
is super critical that you uncheck security gateway at this stage. If you leave security gateway checked, it could cause you some goofy issues with communications between the manager and the firewalls that they were trying to manage.
correct.
Make sure you uncheck security gateway here.
Yep. Exactly. So as Jeff mentioned, you make sure that you uncheck the security gateway. So this will be security management platform only. Click on next. I'm not going to create a new like GUI admin or update the password and all user and all, but I'm going to choose the default admin which I had. But if you choose to, you can create a new one. Click on next. Am I going to allow any IP? But if you choose to, you can allow certain IP or subnet header or a particular range. Click on finish. So this finish will give a wizard window which says just click on yes to continue to start the process. So meanwhile, what is going to happen behind the scene is going to, based on those values which we just entered, is going to bring this instance as a management cluster. Sorry, not cluster, management instance. So, but we're going to jump on those CloudGuard 1 and CloudGuard 2 initial configuration first. While it
just to clarify, you obviously can use a security manager from anywhere as long as it can reach the firewalls in Oracle. So your security manager could live on-prem, it could be a Smart One Cloud manager, etc. So there's no requirement, obviously, to manage Oracle firewalls, checkpoint firewalls in Oracle from Oracle themselves.
Correct. Like Jeff mentioned, any management platform can run in any other on-prem or another instance as long as it has a reachability to your CloudGuard instance to manage those firewall and all.
Correct. Just like just stating the obvious, it's probably obvious to everybody, but in case it isn't, I want to make sure that's clear. Correct.
So these the first task was focused on the management cluster, management instance, which we just covered and showed like what are the different widget configuration which you need to do. So while this happens in the behind the scene, we're gonna move to the task 2, which is the same concept like you need to do admin password. So that way you can connect from GUI. So go to this public IP. So let me just pass this private key for this time, just for test purpose. This is like take me to this instance. Same one. Command is same for creating admin password, so I'm gonna enter the same password, but you enter your own unique password as you need. Save config. Okay. So once you do that, like as you notice, like we didn't enter password, save configuration, and then we're gonna connect to this instance from GUI. So then enter the admin and the password which you just created, and based on that, you should be able to see the first window here. So behind the scene, once you do the we will see this window. And this window has a couple of options here which we need to select. So first is if you want to update the host name, you can do update the value. So we're going to enter the CloudGuard 1. I'm not going to modify the value of management IP because it's coming dynamically from the OCI DHCP. And we're going to keep if you want to update the Gaia admin user and password, you can do that. But I'm going to select the previous value, which I just entered. Then there is a SIG key, which is the communication key to support management platform to talk to the CloudGuard firewall. So this
And
is
one thing that's not mentioned here is this is a one-time password. It's not really activation key is probably a kind of a bad name for it, but essentially it's just a one-time password that we use to establish secure communications with the gateway from management. So this activation key can be whatever you want it to be. It'll be used when you establish, and you'll see that later on when we establish communication from manager to the gateway.
exactly. So you enter that. I'm going to keep for keeping a symbol. I'm using the same value, but you choose your own value. Okay, let's see, what did I enter? Then make sure you select this box, because this our environment, we're going to have like 2 firewall as a cluster. So this is pretty important. You can always enable it later, but which will require you to go to the GUI and update it. But for a test, since you're already on this window, you just select this option. So once you click on go, it's going to ask you to reboot. So click on continue, because in the reboot is going to happen. It's going to make sure this checkpoint has all those SIG keys, password, and the required configuration, all those prerequisite of the checkpoint security gateway gets implemented. Okay, so once it happens behind the scene, you see the manager is still being worked on. So we're going to move to the next CloudGuard 2, so that we can do the similar configuration what we did on CloudGuard 1. So when it happens is reboot, I'm gonna move to the task 3 for the time being, but we'll come back to task 2. The reason being is because it's going to take some time to reboot and configure. Meanwhile, we'll just move to the instance 2. Okay. So in the browser, and I'm just typing this answer like a pretty standard, just accepting the private certificate part. Okay, so once you enter that, you will see that window which we saw in the CloudGuard 1 instance. So we're going to update the host name, SIG key, and admin password. So this is CloudGuard 2. Okay, so it's going to finish and reboot that configuration. So meanwhile, once it happens, so what we can do, I need to, okay, this management platform came fine. So I need to create a new instance for my smart console, because I ended up deleting my old VM. So let me suppose smart console here. The reason being because Smart Console needs to be run on Windows VM, so that's why I don't have Windows VM, so I'm creating a new one for test purpose. Okay, so while this reboot happens, are there any open questions which can be covered? Because it's gonna take some time to
Can you
reboot.
paste the, can you paste the link? I think we have the link to the smart console
Oh,
in the
not yet.
workshop. Can you paste the link to that in the chat for folks if they want to install it? Under
Yeah,
step
so this is
5.
like,
Yep.
sure. Yeah, sorry, Jeff. Yes, you're right. So this is like the task for which to support that, what I did, like I went to this OCI console and I created a Windows VM for my test purpose. And there is a link here which tells you the Smart Console exe. You can copy this link, and using that link, you would be able to install Smart Console. So you're gonna say, I'm gonna do it on my Windows VM, and you'll be able to see what I need to do for that. But in a nutshell, it's just an exe file which you can just double click and install the application, which allows you to connect to the management platform and all, which you will see. So while the Windows VM comes up, let me see it come up.
If we want, I could share my screen. You could log in to the manager from my box.
Okay. But anyhow, this checkpoint, they're rebooting, right? So my
Yeah, it'll
VM,
take a little bit anyway.
yep. Okay. I should not have deleted that.
While we wait, if you have any questions, feel free to ask them in the Q&A or the chat.
Let me see the instances reboot happen. Okay. All right, I think Jeff, give me like 5 minute break. I need to log into this Windows VM. I need to update my password. So I think,
Okay, no problem.
yeah.
So let's do let's join back up at 5 after the hour. So whatever time zone you're in, let's meet back here in roughly 8 minutes. So I have 5 after the hour.
Okay. Thank you.
Thank you, everyone. All right, so it looks like Arun got his Windows VM up and he's starting the installation process for Smart Console.
Yeah, because updating password was taking a little bit like there's so many special characters.
Yep, no worries. It's the beauty of live demo.
Okay, so as you saw, like my Windows VM is up. I was just updating using the object storage. I just pasted on the browser and just downloading locally. So then, in a nutshell, what's going to happen? The Smart Console will be added into my local console here. So what we can do in the meanwhile, let me go back to this task 1 and task 2. Sorry, task 2 and 3. So in the 2 and 3, what we did earlier, like we updated the CloudGuard instance name, password, secret. Now we need to add a route. The reason why we are adding the route, because think of this way, this backend will know how to go to this backend subnet, but this backend has an interface also, right? And this interface of the firewall needs to know how to send it the traffic back either towards the spoke side via the backend in subnet gateway, or if there's a default gateway which will be outside the internet gateway and all. So what we're gonna do, we're gonna connect to each CloudGuard instance, and we're gonna add a route table on those CloudGuard instance to make sure any traffic destined to the spoke VM CIDR, like spoke VM CIDR, goes to the backend and subnet gateway. If you are not familiar with the OCI terminology, the first IP of any subnet is called a gateway. So in our case, it's a /24 subnet. So it will be .1 CIDR. So click on this workshop here. Let's connect to one of the instance of CloudGuard instance 1. So this is 112. So 112 is what? 112 is CloudGuard 1, right? Okay. So enter admin. Click on login here. If you see a lock icon here on the configuration log, you can just double click on and unlock it here. But since I don't see that here, I can just click on IPv static route here. And as you see, the default gateway is via the 1.1 like management side, but we're going to point it to management is nothing but the front end. We have the front end subnet gateway. So for our destination, we can have a specific route for 10.0.0/24 as well as 0.1. But I'm going to add it as a generic value. Not generic value, as like a /16. Click an IP here, 192.168.2.1. Click OK. And click Save here. Same way you do that on the second firewall. Okay. Now those routes are there for /16 subnet and all. So this task 2 of this lab 3 is already complete, which is a adding static route, which we just did by the default gateway of backend subnet. And same goes for the task 3, which we just added once the instance came up healthy, we added the static route. Now in parallel, what I did, like I deployed the Windows VM on my console, smart console, the Windows VM. And this Windows VM is where we did install it, the smart console exe file. So if I go into my remote desktop connection, I should say, okay, I forgot to install, which I should have clicked it further, my bad. Yeah, so it's just pointing to that part where I want to install, but it's pretty quick. It shouldn't take like less than a minute and so. So as it's going to do, like, as you know, we already pointed this smart console. So this smart console we're going to use to connect to the manager, and then we're going to follow along the initial adding the cluster configuration on, and within the cluster we're going to add both of the CloudGuard instances. Are there any open question or comments? And meanwhile,
Everybody's being too polite, or Arun, you're doing such a good job that all questions are being answered on the fly.
I doubt it. Has anyone already explored checkpoint on OCI, or is already anyone is using within their environment checkpoint with OCI, or not yet? Okay, no worry. So once this gets finalized, so let's give it a couple of seconds. So what we're gonna do, we're gonna connect to this console and connect to manager and move to the next step.
It's never as fast as we want it.
Last time it just within less than a minute it was able to install. I was like, what? That was quick. I know it's quick. I just so meanwhile, let's go to console and copy the management IP because we already know the password of it. So if you see it here, I'm gonna go to console and just click on it. Can't wait to click. Okay. Finally, so let me just click on it here. Cool. So you'll see this pop-up window. You can read the instruction if you choose to. And that, in a nutshell, like what we're gonna do, we're gonna go to this the workshop. The first step is like adding the cluster. So if you follow this workshop, like we just connected the cluster, connected to the management server. From there, we're gonna add the cluster here. So you go into this icon here, click on cluster here, click on cluster button here. So click on this wizard mode, which will follow the some initial instruction like how to add the cluster and cluster gateways and all. So we're gonna follow that along. So enter the cluster name. So checkpoint cluster. could be any generic name. This is the, okay. So this is the, if you see this one, the once you click on wizard mode, so we enter the checkpoint cluster name and the IP address. So where would this IP come from? So as you see, this cluster IPv address is the enter secondary public IP address associated to primary interface of the CloudGuard instance. So if you go into CloudGuard instance here, attach we need secondary floating IP. So secondary public IP address associated to primary interface of the CloudGuard, right?
Yep.
So which is like front-end interface.
Front end. Yep.
Yes. And click on it here, secondary floating IP. So public IP, right? Yes.
Correct.
So which you can collect it from there and enter the value here. Click on next. So now this window where we're going to add those both of the members. So we have like 2 members of clusters. So we're going to click on add here, new cluster where CloudGuard 1. And what would be the IP of address? So if you follow the like workshop here, so it will say like we just click on new cluster member, new cluster member. So what's the IP? Enter the primary interface private IP address of the CloudGuard, like the primary interface of private IP, like front end, the first IP of the interface. So if you go into instance here, you can see the IP will be here also, or you can go to the front end and collect the IP address from here. And this is the secure internal communication, the SIG key, which we have been talking about, like how you can make sure that your management can talk to CloudGuard. So this is the key which we configure during the initial configuration of the CloudGuard instance. So you just enter here. Since I'm keeping the same key as a password, so I'm just entered here, but make sure that you click on initialize. So it just it ensures that there's a secure communication and it knows it's working as expected. If not, then you may have to reset those key on your like CloudGuard from the CLI.
Without that, you can't push policy, you can't retrieve logs, etc. It is a requirement. It's mandatory.
Correct. So click OK. You would see that CloudGuard gets added here. Similarly, what we're going to do, we're going to add that another cluster member. And this will be the same cluster member, different instance and the front end IP. So IP, I can just pick it from here because it has only the front end is the primary IP of the private. Enter the SIG key for that one. Click on initialize, and the same way it's going to say the trust established. Okay. Click on OK here. Okay. So as you see, like on the workshop, we just added the CloudGuard 1, CloudGuard 2, make sure the trust is working fine. This is CloudGuard 2, make sure the trust is established working fine. This is just a sanity check just to see both of the CloudGuard 1 and CloudGuard 2 are there. And just to click on next button, then that's where we're going to do finish. So click on next and just to finish here. So once you do that, you would see there's an icon here, so which we're going to just enhance in a bit. So if you click in here, you'll see CloudGuard 1 and CloudGuard 2 here. Currently, all those changes which we are doing, they are local. They're not publish or install anything at the moment. But this is just to show like how you can add the cluster in your using the Smart Console and add the cluster there. So then now the next step is we're gonna populate the interface configuration for each CloudGuard, right? So what do? You go into checkpoint cluster, double click here, click on network management, click on get interfaces with topology. So what it's going to do is going to communicate to both of the CloudGuard instance. and then it's going to populate those instance interfaces, IP addresses and all, right? So as you know, the each 0 is like front end and each one is the back end. So these are like the front end interface IP for CloudGuard 1, and this is the CloudGuard 2, and these are the back end one. So click on each 0. Since we are using the floating IP, so we're going to configure those IP addresses here. So as you see, what we're doing here in this IPv4, enter secondary private IP address of primary interface on CloudGuard 1. That's like a floating IP of the primary interface of CloudGuard 1. So if you go into your instance here, CloudGuard 1, and this floating IP will be as a cluster VIP IP. So click on front end here and choose this value, 1.129. So we're going to select the network type cluster. For each 0 will be used for cluster, and each one, as you will see, the cluster as well as the HA sync configuration sync and all. Oh, sorry, I need to point to the no subnet mask. Click on each one and choose the cluster plus sync. So if you follow the workshop outline here, we just did the cluster part here for each 0, and each one we need to show cluster 1 plus sync, and it says enter secondary private IP address of secondary interface of the CloudGuard 1. So go to the same instance on second interface. Click on IP address here. Click on 2.131. Okay. So now we have the floating IP, as well as we've already populated the E0 in each one interface. So the next step is like make sure all those values there are there. So click on OK here. This is for a VPN link connection. That's a separate use case, but if you can explore it, you can always do that. But for this workshop, just select yes. So click on security policy here. So as you already know, that by default security policies are like blocked everything. But since this is a workshop environment, we're going to update the existing cleanup rule. So I'm going to say allow all, update the action, accept, and I'm going to enable the logging. So you will see in this workshop, in this particular task, I'm not saying log, but in the next task, I'm asking a user to enable the logging here. So you can do it now, or you can follow along in the next step if you choose to. So currently we have the network populated for both of the cluster member. Cluster is working fine, and security policy is there. So then now the next step is we need to publish our changes and then install that particular policy to the cluster member. So once we do that, then you will see all those green check mark over here. So first step would be you need to publish your changes. So if you are familiar with the checkpoint terminology, like first you make sure that your changes which you are doing as committable. So that's why you need to do publish, and then you need to upload those changes via installing policy on the cluster member.
Right. Yeah. Publish is essentially pushing your changes to the management server, and then installing policy is actually pushing those changes to the firewalls themselves so they can do the proper enforcement.
Correct. So to install the policy, click on security policy here and click on install policy. It will populate a window in a bit, which will tell you where it's going to install. You can see policy target. If you choose to see, you can select your changes and all. But since I already know the environment, so I'm just going to select it and click on install. So in a bit, likewise, you will see a green check mark here. And then if you go to cluster member and server, they will turn from red to green in a bit. Okay, take some time to sync up, but it shouldn't take that much time, like a couple of minutes or less than a minute and so. So what's going to happen? as you will, when we see this green check mark in a bit, like this particular lab 3 was more focused on how you can deploy those, not deploy, how can do the initial configuration on the management cluster, management VM, as well as the checkpoint CloudGuard cluster, and how you can add the cluster member from the smart console, how you can push the policy and initial configuration. So then next step, as you Jeff already know, the next step, that's where we're going to test out the traffic validation, like how you can actually inspect the traffic, like east to west traffic, north to south traffic, and block policies and all. But currently I'm allowing all policy, but as you already know, familiar with the, as you see, this is everything is working fine, but you can always add more policy on top of it, right? So like any security policies and all, you can do that. Let me just delete it here.
Correct.
Okay. All right. So let's move to the next step. And as I mentioned, in every lab environment which has an instruction how to get yourself familiar with that. So click on next button. Okay. So traffic and high availability validation. So how we have categorized this traffic validation in like 3 or 4 segments. One is like north to south inbound traffic. So the intention would be I will be trying to connect from outside, like my public internet, to the spoke VM. And to support that, what is the required policy, either netting on or as well as security policies, which we will cover. Then I will try to connect from those my VM to public internet and see I can connect to Google or any other outside internet connectivity. Then we're going to focus on east to west traffic. So east to west is like a spoke database VM, like can connect to database to like web to spoke or database to web, however we want to do. And then you see the traffic gets inspected by a firewall and all. And one would be like traffic reaching to internet gets inspected by a firewall, as well as traffic coming from internet is like north to south traffic reaches to web VM. So to support that, like, and then in the end, we're gonna, I'm gonna skip this part, but in a nutshell, it's nothing fancy. It's just a service gateway which is connected to object storage network. But you can follow along this particular task just to know more about it. Then in the end, we're gonna cover the high availability use case just to see once the primary failover, do we see traffic resume at the same time? Do we also see the public IP gets moved from primary firewall to standby? Okay. So for north to south traffic, as I mentioned, like we're gonna do connect from outside to web and database spoke VM. How would you connect from outside? So as you know, like in each instance, not each instance, like on our CloudGuard primary firewall, we have a floating IP available here, right? This floating IP will has a public IP associated with that, right? So what we're gonna do, we're gonna use this public IP to connect from outside. But once the traffic hits the OCI, like the particular VCN environment, that public IP gets translated to this private IP, right? So on the firewall, we'll see this IP hitting it there. So what we're gonna do, we're gonna create some net policy, and before that, we're gonna create some object of this IP as well as the instances where you want to go, and we're gonna create some net policy. We will see how you can connect from outside. But it's not required. If you have access to or a mean to connect to a web spoke VM, you can connect them directly if you choose to. All right, so let's go into instances here just to see what are the objects which will create. So we're going to create web spoke VM object, which is 10.0.0.11, and this is the database VM 1090. All right. So what's the first object, like web app VM1? So how you can do that? Let's go into smart console here. So there are many ways you can do it. Like one is like API driven as well as CLI. So if you are familiar with the CLI console, you can click on command line here. From there, you can create those objects here also, as well as from the API or any other mean. But since I'm using the GUI, it's easier for me just to click on network and host. Enter the network, the object name, and we're going to enter the IPv address of web VM. So this is the web VM here. Okay, click OK. So once it does that, it's the object, you can search it from here, F1. So it should point it to the web F1. And if you want to create another object, you can just click on it and clone. And clone will populate this value as well as the which you need to modify based on the database VM. So database VM is 190. Then let me just click on it and create another clone object, because for the front end IP, which I've been talking about. So this is the front end private IP 1.129, which you need that here. This is the workshop. It says we created web app here. We created, this is the front end IP. Let's copy this name here. Okay. So we created front end web database, which we just did. But how would you connect to? How would you verify? Like not verify. How would you separate your each connection to that public IP? So that way, to support that, we are using the TCP service and different unique port. So I'm using web application VM is like 177 port, and another one is 1778 port. So you can click on this network services here, click on more option here, click on service, click on TCP. From there, you can enter this web app 177 and select the port 177 here, click OK. Let me just search it here, 177 again, just where it will tell me this service, and you can clone it.
And like we mentioned before, you know, what we're doing here is just only using one public IP for the VIP to allow us to do this. And this is why we're doing individual ports per VMs. But like we said before, you can assign multiple floating IPs and assign statically those IPs to these VMs if you wanted to, and add them through to get access to them directly.
Correct, exactly. All right, so we have those services running, object which we already created, web and database, everything is fine. Now how would you support that netting from outside, right? So the first thing which we want to do, we want to assign an external zone-based policy restriction on management interface, like which is like front end. So in that way, there is no netting happens on the front end part, but the netting happens after like beside the management cluster IP, and then it happens on the checkpoint, like web, like traffic when hits the from external side, it goes to the web VM on particular port, then gets translated to the web app VM and a particular service. You will see like how we are creating them, as well as like traffic hits from 1778 port, it goes to the database VM on this particular 22 port, like SSH connection. And the first one is like on particular security manager, just to see it does no netting happens around that management cluster itself. All right, so this is logging which we already enabled here on the allow lag policy, but let's click on this each 0 first. So go back to a cluster here, network management, E0, modify, use specific external zone. Okay, click OK. So this already tracking enable log. So but we're going to do create net policies. So let me add the net policy here and to top. So this net policy, if I just follow it here, so no net rule manager, let me just copy the name as it is. Then select the checkpoint manager, it will be this one. original, any source, translate original, and policy targets. It will keep the same. Now just add another net rule for web and database VM. So we're going to add one by one. So click tool below. I think, as I mentioned earlier, like once it hits the firewall will see the front end private IP, right? So that's why we're selecting the destination. And this is the service. So the service will be web app VM, which is 177 port from outside. Original, and destination will be our web VM. And translator service in our case will be SSH. Okay. Let's copy it. Okay. So copy paste and so also work, but I just did it quickly. Traffic database. External front end will remain same. You can click on it and DB 1778. Okay. This looks fine. So we added like 3 different net rules. So you can do a sanity check just to see everything is as expected. But since I'm doing it, I know that everything is a web and database, and they're pointing to the right port, using the right port, incoming port, and pointing to the right web and database VM and the SSH port. So you can select your policies here, but before you do that, you just publish your changes as I mentioned earlier. So in that way, management platform knows what the changes which you want to push. And then you click on install policy. Okay. So while it happens behind the scenes, so hopefully it goes through, obviously. So once it goes through, then what we're going to do, we're going to use the front end public IP to connect from outside to 177 port as well as 1778 port. And it should redirect us to the web VM as well as database VM. So as you see, it was successfully applied. So let's connect to this terminal here. Instance public IP. So as you notice, like I was able to connect from outside using the public IP of the front end interface and 177 port, and you will see the IP address is pointing to the 111 and as well as like 1.90 of the database view. So that's like the first use case of this traffic validation is like using those public IP. I can connect to database VM as well as the web application VM. So that's the first use case of the traffic validation which we wanted to focus, like north to south inbound traffic. And if you are curious just to see how the policy, like do we see the logs on there, you can always go here, select for a particular port, enter for example 177. You'll see there's a traffic coming from my public IP and it's being netted. And it's translated to 0111 and the particular port of 22. Same way you can search like 177 if you choose to, but you will see the traffic is coming there. So, okay, now let's move to the next traffic validation, which is like outbound. So as I mentioned, for outbound, we are using the gateway, like the front end internet gateway, which is like, sorry, there's an internet gateway associated with the front end subnet, which allows us to go out. So to support that, we still need some, make sure that once the traffic hits from Spoke VM, we have like hide net rule. So in our case, it's like a web app VM and database app VM, they are trying to connect outside. So if we try to go to Google here, if we do ping google.com, like it won't be able to, like you won't be able to connect outside unless you add those net rule here. So let's select the VM here, VM app one. So click on the net here, add automatic address translation rule. So if you click here first, let me just cancel this here. Yes. So it will add a automatic net translation rule here. So let's just click here one more time. Okay. Same way you do that for database VM, and it will create a hard net rule. Okay. So both of the net rule are there now. So you can just click on publish because our policy is allow all. So I'm not going to add explicit policy, but if you can choose to, you can do that. And then click on policy here, click on install policy. So this will, like once the policy gets applied, and this is the traffic validation is node to sound outbound traffic, like we can reach to internet using those web spoke and database spoke VM, and based on those hide net rule. Okay, so this google.com everything working fine, but if you are just curious, you can see, let me just keep running. You can go into policy here and search for service ICMP.
ICMP requests or echo. Yep, that'll work.
So this is like our web VM is trying to reach to ICMP, and you see the traffic log here. And as you notice, like we are going to the primary CloudGuard 1 only, like all of these policies are and the traffic is going to the CloudGuard 1 because CloudGuard 1 is our primary firewall at the moment. Okay, so I'm just going to cancel it here. So now the next part is like, as you notice, we covered the inbound and outbound. Now we want to focus on like how the east to west traffic will behave. Like for east to west traffic, we want to send the traffic from web spoke VM to database as well as vice versa. And we should see the traffic goes to the firewall of CloudGuard 1 and it gets inspected. And since we have the allow policy is allowing all, but if you want to block a certain CIDR and all, you can choose to, you can do it. So for test purpose, let's go into our web spoke VM. So let's do ping to this IP here. Okay. Same goes for ping. So as you see, web spoke can talk to database and database can talk to web. And how does the routing work? So as I mentioned in the beginning, like I wanted to pinpoint here. So let's go to the VCN here. So this database VCN wants to talk to web VM. So it's what it's going to do. It's going to go into this from this subnet of this instance. It's going to see a route table. It's going to come to the DRG. From DRG, as you already know that we have an attachment from each spoke as well as the firewall VCN. It will see an attachment to the DRG. And this is our database VCN. It will see an attachment. It will see there's a route table. So it will go to the two firewall route table. Then it will see, okay, I need to go to the firewall VCN. That's my next hop for all those SADR. So from the firewall VCN, you will see there's a VCN route table. So it will go to VCN ingress route table. From VCN ingress route table, it currently I have 00, but if you had only these two, then it will see, okay, there is a 2.131, right? Then it will see, okay, 2.131 is what? Backend's private IP of the firewall. And which firewall it is? It is a CloudGuard 1 firewall. So we click on attach VNIC here, and then it will see the CloudGuard 1. So that's how it knows like how to send the traffic from web spoke to database as well as inbound and outbound. So if I go into my firewall here now, and if I try to do SMP request again. Yeah, so this is one of the example of web spoke VM trying to talk to database spoke VM, and what is the ICMP service, and it's going to the CloudGuard 1. And what is the match? So currently, like we have only one rule, but you can add more rule if you choose to. So that pretty much covers the traffic part of north to south, inbound, outbound, east to west traffic between web spoke to database. There's another task which is like object storage. You can follow it along. I'm not going to cover it, but in a nutshell, it's pretty standard. You add a route table on each firewall to see in this is a S1 SADR. Like you say, this is the my object storage IP, public IP, and you say only don't go to the default gateway, which is of 1.1 like front-end subnet gateway. Go to the trust subnet gateway. And in this trust subnet, once you do that, as you already know that we have a trust subnet route entry, which is like going to the service gateway. So if I go into backend subnet, follow the backend, and this backend we have the route entry, and which is like via service gateway. So it will ensure that any traffic towards the object storage within your S1 region or within your region SADR, it goes to the service gateway. It doesn't follow the internet gateway traffic. Okay, so this you need to add those route entry on each firewall, and then this backend route entry which is already there. So behind the scene is just once you follow this object bucket and try to download the file here locally from the web spoke and database spoke also, you will be able to see those value on this CloudGuard and the traffic here. All right. So now the next part is like if there are no open question around the traffic part, traffic validation, I can cover the high availability failover scenario, like how would you see the traffic from the HA point of view. All right, Jeff, I will continue from the HA part then.
Yep, sounds good.
All right, so let me disconnect it here. Connect to another instance. All right, so as you noticed, like we already in the beginning, I showed like what is the floating IP, where it is present on CloudGuard, which is already covered. So the intention is we're going to do HA failover, and how you can do the HA failover, there are some prerequisite only for this particular RAT1 release, and Jeff can comment more about like when this will be available, but we need to run this some basic command in expert mode.
Yeah, essentially we're updating the certificate bundle to in order for us to talk to the API, and this should be fixed in a soon to be released image to the Oracle marketplace. We won't have to do these couple manual commands to update that certificate bundle.
Correct. So what's we're gonna do? We're gonna connect to each CloudGuard instance. We're gonna go into expert mode. So there's a command here which you can just copy, or if you already know the command. Okay, so once those commands run successfully, you can exit or you can stay in this expert mode. From there, you can do HA failover, but I will show from exit part. Same way, you can go to another instance, do the same, run the same commands. All right. So now, since we already completed the both of the commands on both instances, we should be able to do HA failover. So there are two ways, like either you can do reboot the instance or you can run it from a command line of the CLI of the cluster. So you can, to bring down a cluster, you can, before bringing down, you can show the cluster state. If I go into CloudGuard 2, it will tell me which one is primary and this is the standby. If I go to CloudGuard 1, sorry, set cluster state, show cluster state, it will tell me CloudGuard 1 is the active and another is the standby, right? So what we're gonna do, we're gonna bring one of the CloudGuard primary firewall as a down. Okay, so if I do state here one more time, you will see this is currently down, the CloudGuard 2 became active, right? And if I had that traffic running, let me see if I had the traffic running, not yet. Okay, so behind the scene, what it does, based on the dynamic group and policies, it moves the floating IP from primary firewall to the CloudGuard 2. So what we're gonna do, we're gonna show the CloudGuard 1 of the instance unique, and let's focus on front end here. Go to CloudGuard 2 at the same time. This everything is already written part of this image. So the partner provides the plugin to move the floating IP. So as you see, CloudGuard 2 just move the IP. And if I go to CloudGuard 1 front end, you won't see that IP there anymore. So those IP, like that's why it's called floating IP. Those are dynamically moved from one firewall to another one. And as soon as those floating IP on both the interfaces, because we were doing the east to west traffic, so it needed like backend interface, you will see your traffic supported and it gets routed also. Any question like on the failover part?
One thing that's can be a gotcha in case you run into this is sometimes folks have compartments where their instances are separate from their network resources. So make sure that your policies cover both compartments in order for the failover to work as designed. We've seen instances of that where it was kind of we weren't sure what the deal was, but it was simply just a compartment issue. So make sure you know what compartments have control over which resources.
Correct. And in case if you are not sure, then you can always ask the partner or the OCA team. But in my case, I had a separate compartment where I'm creating the complete network resources as part of the same compartment. So the next lab of this session is just a pretty straightforward, like deleting the environment, which I'm not going to focus, but you can, if you choose to, you can do it, but that's not the focus of this workshop. But it gives you like a step to follow it if you do it.
So I'm pasting our email addresses into the chat for everybody to take down. I know we went through a lot of content fairly quickly, but we were recording it, so you can go back and follow through at your own pace. Obviously, you can go through the workshop at your own pace as well. And if you have any questions, after this, after going through it a few times or whatnot, or just in general, you can send us all an email and we'll be happy to help you going forward. Appreciate you guys all taking the time, and Arun, really good job. Thanks, Sean, for jumping on.
All good, all good.
Thank you, Sean.
Hope you all have a good evening, morning, afternoon, wherever you're at. I am going to bed. I think Arun is too.
Yeah.
Cheers, buddy. Enjoy it. Sleep
Yes,
night.
sir. Yes, sir. All right.
Cheers, guys.
Arun, any last comments?
Now, thanks for everyone. As Jeff mentioned, like if you have any comment or question, you can always reach out to us over the email directly.
Yep, happy to help. Appreciate it. Thanks, everyone.
Cheers, guys.
Okay,
Good night.
Bye.
You bet. Take care. Bye-bye.